Said I was going to continue this last night, but that did not happen. I fell asleep hard. Okay. So the last thing I was trying to do was figure out this. I kept coming up with weird or opposite of what this is supposed to be. Oh shit. Hold on. Hold on. Okay. Much better. So, I got stuck on this last time and couldn't figure out what I should do. So, is either an operator error. Like, I simply do not read this well enough, or this isn't drawn well enough, or this resistor is messed up. I could test the other ones, and if I get the same result, I would have to assume that they're all same. So, negative connection is in the COM, positive connection is in everything, including ohms, and that resistance is what I'm going for. I'm going to put this back on. Maybe it'll stop slipping around a little bit. Nope. I don't need this. I'm just going to take it off. Ah, that's so much better. That does not move around. Much better. Okay. So, I got the negative, the positive. Looking at this one, it says transistor test, NPN and PNP. Refer to the parts list and find an NPN transistor. This is the 2M3904-338. Refer to the figure J, page 16, for locating the emitter, base, and collector. So, we get to go ahead in the pages, which I did before, but I didn't look at it too close. And then I did it again and realized, oh, I should have looked at it. And then I realized I was doing it right either way. Page 16, header, that's not what we're looking at. NPN transistor, the flat side, that's the flat side. E is on the left, B is in the middle, C is on the right. So, emitter, base, collector. That is what that is. Mount, so E lead is in the arrow hole and flat side is the same direction as shown on the top legend. I don't really have to pay attention to that too much. PNP transistor, flat side, same way. E, B, C. Emitter, base, collector. It's same way, so flat side, emitter, base, collector. So, I was doing it right the last time. Now, the confusing part is, using an ohm meter, I've got a multimeter, connect the transistor as shown in test A. This picture here could mean connect the positive to both the base and the collector, or it could mean only touched the base. Technically, I mean, the picture looks like it means touch both the base and the collector, because it's like over top of both of them, and then poke these other ones. You know, this one shows clearly just should touch the base. So, I don't know. Your meter should be reading a low resistance. So I'm gonna assume low resistance means 0 or at least this is a high resistance, says it's 1 mega ohm. So I'm gonna assume less than 1 mega ohm. So we've got positive guy. We're gonna just try touching the base. Just because, I don't know, I don't trust that I was doing it right the last time. So, just touching the base and the emitter. Yeah. This is difficult. Okay. We got 40 mega ohms. Just touching the base and the emitter. Close to 40 mega ohms. That would be that, if that's what it means. But I think it means to touch the base and the collector and then the emitter. I'm getting like 30 mega ohms. Am I not touching all of these? Let me hold it in place. Maybe that will help me. This is difficult. I don't know. I don't know. I'm just gonna stick it between these. That works. And that's definitely... I'm getting 27, 30. Zero? What am... 30. 28.5. 20.6 mega ohms. We're still in mega ohms. And it says your meter should be reading a low resistance. Switch the lead from the emitter to the collector. Your meter should again be reading a low resistance. So let's put that on there. That's a low resistance. It's reading in the kilo ohms. It's like, no, it's a singular ohms. Kilo ohms. But yeah, this is, okay, so touching touching both of these with the positive one, and then touching this one, the collector, to the negative, or touching the negative to collector, gives me a low resistance. Yes. Touching it to the emitter is not doing. It's giving me mega ohms. So I don't know what's supposed to be going on, but I don't think it is going on correctly. Clearly I do not understand how that works. Let me see if I can get one of them PMPs. I don't think. Let me see here. Put these off to the side. Here. Okay. Squeaky, squeaky. Okay, so here's like all these things. I'm gonna put these headers back. Okay. There's another 904. There's another 904. There's a 906. 904. 904. It's supposed to be 5 of those, and there are, so that's good. And the 550 and the 8050 and the 8550. So let's try another one of these. 3904. No, we're still getting like 30. And even if I just touch the base, it gives me the same, almost the same. So, I don't know. This one of the 904s again. Low resistance? I don't know. That's the one I'm looking at. These are all 904s. We'll put those away. And I'm gonna check the front again here. PNP is a 906, which is that one is a 906. I'll put the other two away. Okay. The NPN is an NPN. That's the NPN. This is the 904. The 906 is a PNP. Unless I'm just not understanding. Whatever. Okay. Well, we'll connect. That one's the 904. Okay. Connect the negative one in the middle here and positive one on this side, and I'm supposed to get a high resistance. Keyword supposed to. They're connecting. I know they're connecting, and I'm getting nada. 0 mega ohms. Nothing. Is this? I'm checking. I'm checking again. Resistance measurements. Set the function switch to the ohm position, and that is the ohm position. Insert the red test into the positive ohm jack, and the negative into the negative com jack. Touch the test probes across the circuit or component under the test. It is best to disconnect one side of the circuit under test so the rest of the circuit will not interfere with the resistance reading. Read the resistance in the display. This is a transistor, but we are measuring resistance. Continuity, frequency, I don't think it would be listed as something else. If it is, you know, I don't know, maybe it says something different. Probably not. Okay, so I've got things plugged in correctly. Black is negative, red is positive, it's on the ohm thing, it's in the ohm jack, and apparently I'm not getting it. I don't know. Switch the lead from the emitter to the collector. I wish this would say, specifically, connect the positive or the negative to both the base and the collector, or connect it just to the base. It says just follow this picture. Well, technically what it looks like it's doing is that, and what do you mean beep 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 beep? I'm still using you. I don't know. I'm gonna switch it off, turn it back on again. I'm pretty sure this thing beeped at me because, like, hey, I've been on a long time. Stop it. Your meter should be reading high resistance. Either of those ways. 1 mega ohm to infinity. I would love to see an infinity amount of resistance on one of these things. Just, it's not gonna happen. Okay, so let's try it with the PNP. Refer to parts list and find PNP transistor. Refer to figure K for locating the emitter, base, and collector. I already did both of those things using an ohm meter, or a multimeter in this case. Connect the transistor as shown in test C. We got the plus on this side, the negative in the middle. Click. Okay. 0. We got 0. Success? I would call that success. Both are definitely connected. Your meter should be reading a low resistance. I'm getting nada, so that's good. Switch the lead from the emitter to the collector. So we're gonna do this now. And it should still be low resistance, and it's not. I'm getting 40. Pretty damn close to 40. That's the collector. Switch to the positive one. From that one to that one. Seriously. Either this is written wrong, these transistors are wrong, or I'm just doing it wrong? I don't know. Yeah, I'm getting 39 something. It's supposed to be low. So, I don't know what's going on. Do not know what's going on. Again, never done anything with circuits before, so I don't know what is supposed to be the proper way to do this, so I don't know about this particular section. Using ohm meter, connect transistor shown in test D. Meter should be reading a high resistance. Looks like it's going across both the base and the collector. And then we've got, that's the positive one, and touching the emitter. I'm getting nothing. And I'm supposed to be getting a high resistance. Just cute. Or it's listed wrong in the parts listing, or I'm somehow reading it wrong. That one definitely says 4. That one definitely says 6. Alright, and then try this on the collector. Okay, am I understanding this wrong? Like, no. That's low resistance. Both of those are low resistances. Close to 0. Okay, so, Does 0 mean close to low resistance? This says high resistance equals approximately 1 mega ohm to infinity. This is telling me I'm supposed to be getting a high resistance. This is telling me I'm not getting... What am I missing? What am I missing? Alright, well, let's take an interlude. And look up how to measure transistor resistance. 4 ways to test a transistor. WikiHow. I'm so glad they use pictures instead of this is what, drawn pictures. I mean, I guess. I mean, alligator clamps would be useful. I don't seem to have any. See, there we go. This one, what does it say? Determine which leads are the base emitter. The leads are round or flat wires extending from the bottom of the transistor. They may be labeled on some transistors, or you may be able to determine it by this circuit diagram. Clamp the black probe at the base. This would be a lot easier if I had clampies. That I do not. Touch the red one, or the positive one, to the emitter. Emitter? Emitter. And the black one to the base. So, what are we measuring? Note whether it's high or low, and it should give you the same Let me take a look under here. No, nothing. Alright, what does it say? It doesn't say whether it's one or the other, but okay. Alligator clamps would make this so much easier. Alright, well, okay, so clip the red one. Where is it? Okay. Clamp the black probe to the base. This is negative. This is this. Either of these things. Okay. And the red one to the emitter. So, this setup, or this setup, gives me nothing. 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 Okay, so I get 0. Low resistance. That's accurate to this. Okay. Touch the red probe. Blah blah blah. And then move the red probe. This one to the collector. Collector flopping all around here. 40. The display should give the same reading as when you touch the probe to the emitter. It is not. It is not. I mean, Paper is not the problem here. Paper is definitely not the problem. I don't know. Is it incorrectly diagrammed? Like, what am I missing? Okay. Let's check this again. Let's check it again. Okay. Transistor and amplifier. Blah, 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 blah. Wear safety goggles during all assembly stages. This is still not an assembly stage. This is terrible. Okay. What? I need calipers? I don't have calipers. I don't even have a ruler nearby. Oh well. Okay, so looking at this, looking at this. Here, this is NPN. This is PNP. This is PNP. This one using NPN, so we'll just look at this one. So, there's the flat side. Goes like this. And we've got an arrow over here that says emitter. And that one in the middle in the back is base. And the one on the left is collector. I'm pretty sure I'm not misunderstanding that. Emitter, base, collector. Emitter on the left, base in the middle, collector on the right. This one's a PNP, and the PNP is the same. Emitter, base, collector. So I'm not misunderstanding that, at least according to the diagrams. I don't know. So both of these readings should give me a low resistance. Both of those readings should give me a high resistance, and essentially it should be the same value. Now, touching okay, well, okay, this one on here it says remove the black probe and clamp the red probe. Shush. Clamp the red probe to the base. So this picture is misleading if it only wants me to touch the base. It should be coming in down here and only touching the base, because that makes it look like it's touching both of them. So that is confusing. This is the NPN. Touch the black probe to the emitter and the collector. Even that is misleading. It says touch it to the emitter and the collector without separation, so it's like connected to both of them? I don't know. We getting... Stop moving around. So clearly, Campies will help you with this. Okay, so we're touching the base. If I could... Stop it! That's annoying. Alright, okay. Right now. Touching the middle one. I'm getting 38 something. And 34. This is that. No, this is not that. This is high resistance. Fucking nothing. 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 Okay, well, if 0 is high resistance, then okay, we're good now. But I think I'm getting like the opposite, and so I'm confused by this section. I don't think it goes over it well enough. The pictures are confusing. This is confusing. That is confusing. I'm gonna continue on and assume that this is correct, but this section is not all that great. So we're gonna move on to the diode test because I'm tired of doing that. So refer to the parts list and find a diode. Where'd I put it? Here it is. Found one. There's my diode. We're gonna put the black strip on this side over here. We're gonna still need this. So refer to figure H on page 16. I understand not wanting to like print the same thing twice, but it would be nice to have it both in the same location. Diode. Be sure the band is in the same direction as marked on the PC board. The band on this side indicates the cathode, and this is the anode. So, cathode, anode. The end with the band is the cathode, and vice versa. Using an ohm meter, or in this case a multimeter, connect the diode as shown in test E. Negative side to the cathode. Turn it back on to ohm. Okay. That. Flop it around. Okay, and that one. What are we getting? Point. Okay, so we got less than a mega ohm, which, according to this, is a not high resistance. Now connect it the opposite way. Okay. Alright. Negative side on the anode, positive side on the cathode. Your meter should be reading a high resistance. Typical results read approximately 1. Stay in place. 1 mega ohm to infinity for silicone diodes. I am so glad that this is reading 0. Alright, either this is fucked up, my brain is fucked up, this is fucked. I don't know what. I do not know. It's set to ohms. I don't know. I do not know. Negative side, positive side. I'm getting nothing. I'm getting nothing. I do not understand this. Not getting nothing. Okay? That means I'm getting something. I'm not getting anything. Fuck, man. You would assume, based on how simply this is written, that it would be that simple, but I don't fucking know. Let's leave those curves in there. That might help me. Negative side, positive side. We're getting less than an ohm. I'm sorry, less than a mega ohm. We're getting 7. 0.7 mega ohms. So what? I don't know. That's the black band. Unless, like, I don't know. There's another black band on here? There isn't. There's a black band on that side. It's supposed to be low. Fuck if I know. Hey, it doesn't say positive or negative infinity. So maybe it's 1 mega ohm to negative infinity. Fuck, man. Positive on the band side. Negative on the other side. I am not getting shit. So either this is just purely no good for measuring diodes or resistors. I mean, I've got an old Radio Shack one I could try, but I'd have to go get it. Fuck, man. I don't know. I do not know. Put this back on here. But I don't know. I don't think something is going wrong in the process, and I don't know what it is. So, well, I'm almost to assembly. Here's assembly right here. There's still more information right there. But holy fuck. I think I'm gonna go get that other fucking thing and see if I can get any of these to work, because I don't know. They should be working, and I mean, this is not the most expensive multimeter that I purchased, but it should be doing the job. So I'm gonna go with the other one and take a while. Okay, so I've got my Radio Shack. I don't even know how old this is. Clamp on. Clamp on. Oh, this is a clamp. Alright. Word about safety. There should be more than one word about safety. Clearly, I only need to worry about ohms right now, but, alright, we're gonna try this. I may need to put batteries in it. Yes, I do. AAA. One AAA. Ah, my goodness. Such a pain in the ass. I'm gonna sneeze. I sneezed. Excuse me. Okay, let us try this one more time, and very much hopefully with more success. This, I actually took it apart to look at it. There's an old one, maybe? I don't know. That might be the one that I took or put in more recently, but I'm not gonna trust it either way. I can find it out later. This goes back on like that. And I've got things over here. Get on there. Okay. Get on there. Go away. Okay, so all we need this. Gonna try this again. Just waste more time. At least it comes with banana plugs, you know, I guess. Calm. Cat 2. The negative and the positive. Then we're going to switch it to ohms in the RX1K range, because what? Dude, that's even bent. That is bent. That's awesome. Okay, so we'll try the diode first. We'll just try the diode first. Less to fuck around with. Okay, connect the negative side to the cathode, right? Yeah, cathode. Okay. Negative side, cathode. Flat down on there. Good. We're watching this. And the positive side to the anode. And I am getting nothing. Nothing. Let me touch them together. Okay. Actually, I did read something in this one. There's an ohm adjust, which is on the side, but it's actually pretty good right there. So this side to this side, we got nada, nothing. That is hopefully what we are expecting from that. Your meter should be reading a low resistance. Okay, good. Now now this test. Positive to this side, like that, and the negative to the other side. Okay, and what do we get? We get some resistance. So, you know, I don't know, if I'm just not understanding it or what, like, I don't know, but let's see here. RX1K. I don't actually know what that means. Damn. And this is why you keep the instructions handy. Resistance. $10K? It doesn't say 10K. What are the specs? Installing the battery using the multimeter. Blah 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 blah. Measuring current. Measuring voltage. Is measuring resistance. Make sure that the circuit under test has all power removed and any associated capacitors are fully discharged before you make a resistance measurement. Good thing I haven't installed it yet because, okay, never connect the test leads to a source of voltage when the function selector is set to either of those ohm things. Let's just assume it explodes. When you measure the resistance of a component in a circuit, disconnect one side of the component you are testing. It happens to not be connected at all. I would assume, based on this, that you can test the resistance of something without being connected to anything whatsoever. So yeah, follow these steps to measure resistance. Set the function selector to either of these things. Touch the test leads together, then rotate ohm adjust on the side of the multimeter until the needle points to 0 on the top line of the multimeter. It's pretty close. Good enough, I suppose. Okay. 0. Touch the test leads together, rotate the ohm adjust till it's 0. Touch the test leads across the circuit you want to measure, or remove one of the leads, blah blah blah. If you want to measure from the blah 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 blah. Then read the top ohms line on the multimeter. If the function selector is set to Rx 100 ohms, multiply that reading by 100 to compute the resistance. For example, if the needle points to 1, the resistance is 100 ohms. 1 times 100 equals 100 ohms. If the function selector is set to Rx1k ohms, multiply that by 1000. So, we got the plus side on this side, the negative side on this side, and we get, technically, wouldn't that be the high resistance? Because it's on that side. Fuck if I know. I've never done this before. We get no movement. No movement whatsoever when I do this. No movement. We got the positive on this side and the negative on this side. No movement whatsoever. Doesn't that technically mean it's infinity? Oh my goodness. Why don't I understand this? On this setting I have 1050. Let's set this lower. And readjust it. Okay, and then try the same again, just to make sure. There is no movement. No movement. No movement. Nothing. Okay, so now if I do the opposite, negative on the other side, now I get to 3.5. So 250. 250, I think. This gives me 250. Ohms. This gives me infinity ohms. It doesn't move the meter. I think, I don't know. If you are identifying cathode or anode ends, or the type of transistor, PNP or NPN, the actual polarity of the multimeter's voltage is the opposite of the polarity suggested by the test probe's color. Suggested by the test probe's color. The red test probe is the negative source and the black test probe is the positive. What? What? Oh, no. If you're doing it the wrong way, or the right way, or the wrong way, whatever, then it's as if, you know, one way or the other. Fuck it. I don't know. man. Do not let any water drip inside the multimeter when cleaning it. Alright, well, je ne sais pas. Je ne sais pas du tout. Alright, I'm moving on because I don't know. I don't know. Clearly, I'm not understanding it, or I don't have the right equipment, or this is just written poorly. So whatever. Okay, we're moving on. I'm done with that. I tried for a very decent amount of time. I couldn't. I needed help with that, so that's awesome. Integrated circuit. IC audio amplifier. We're finally getting close to some kind of actual something here. This radio kit contains two separate audio systems. The first is an integrated circuit, IC, and the second is a 5 transistor circuit. The objective is to show you how these two circuits function and to compare the performance of each. We will begin the radio project by building the IC audio amplifier first. The purpose of the audio amplifier is to increase the audio power to a level sufficient to drive an 8-ohm speaker. To do this, DC, direct current from the battery, is converted by the amplifier to an AC alternating current in the speaker. The ratio of the power delivered to the speaker and the power taken from the battery is the efficiency of the amplifier. For the audio amplifier, we use the integrated circuit IC LM386. In figure 2, you can see equivalent schematic and connection diagrams. This little doodad, it's got that little thing on that side. Gain 1, input 2, negative, input 3, positive, ground 4, 8 gain, 7 bypass, 6 VS, 5 V out. So it goes through the inputs here and comes out here. That one's the ground, those are both gain, and that one's a bypass. And I do not know the significance of most of those things. In a Class A amplifier, transistor on over entire cycle, the maximum theoretical efficiency is 0.5 or 50%, but in a Class B amplifier, transistor on for half a cycle, the maximum theoretical efficiency is 0.785 or 78.5%. Since transistor characteristics are not ideal in a pure Class B amplifier, the transistors will introduce crossover distortion. This is due to the nonlinear transfer curve near zero current or cut off. The type of distortion is shown in figure 3. In order to eliminate crossover distortion and maximize efficiency, the transistors of the audio amplifier circuit are biased on for slightly more than half of the cycle. Class AB. In other words, the transistors are working as Class A amplifiers for very small levels of power to the speaker, but they slide towards Class B operation at larger power levels. To make the LM386 a more versatile amplifier, 2 pins, number 1 and 8, are provided for gain control. With pins 1 and 8 open, the 1.35 kilo ohm resistor sets the gain at 20. See figure A. That. The gain will go up to 200. See figure B. 4B, sorry. If a capacitor is placed between pins 1 and 8, the gain will be set to any value from 20 to 200 if a resistor is placed in series with the capacitor. The amplifier with a gain of 150 is shown in figure 4C. The amplifier in our kit with a gain of 150 is shown in figure 5. Capacitor C40 couples the audio signal from the volume control to the input of the audio amplifier. Capacitor C43 blocks the DC to the speaker while allowing the AC to pass. I'm gonna be honest and say a lot of that just kind of went over my head. Certainly I can understand it, but I don't have enough basic knowledge before this to understand kind of what it's talking about. And again, it's been a long time since I've even talked about circuits, and certainly since I've been in some kind of class where circuits were involved. Alright, assembly. Yeah! I'm gonna get my fucking safety glasses on. Alright. We will begin by installing resistor R43. Identify it by its color and install it as shown on page 4. This is page 8. So I gotta go back again. Yay! What is it referring to exactly? Yeah, okay. Yeah, install it on page 4. Right. It does not show how to install it on this page. Yeah. It shows that the color. It shows the color. It shows the identification on page 3. I don't know. Alright, we're looking for R43, which happens to be this little guy right here, which is gold, brown, purple, yellow, backwards. This one. And we could, if we wanted to, double check this. Yellow, purple, brown. It says violet, so we'll call it violet now. Yellow, 4, violet, 7, brown, 10. So 470, 470 at 5%. And number 43 is 470 ohms at 5%. That is number 41, isn't it? No, it's below. That one is that one. No, I took the wrong one. I took the wrong one. Na, 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 na. Good job. Let's try this again. 45 is that one. 44, 43, 38, 43. That's 43. Okay, let's try it again. We got brown, black, and brown, which, according to that, should be 100 ohms for this cheating. Looking at it, let's come back here. It says brown, black, brown. 100, 100 at 5%. So this is number 43. Identify the resistor by blah 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 blah. Be careful to properly mount and solder all components. Diodes, transistors, and electrolytic capacitors are polarized. Be sure to follow the instructions carefully so they are not mounted backwards. Check the box when you have completed installation. Check the box? Oh, these boxes. I was like, I unpacked everything from the box. Why would I need to check it? Those boxes. Okay. Let's see. Where's safety classes? Yay! Okay. R43, right there. We're gonna find it on here, and this is close by the speaker. We got up here R43. This guy comes in. Both of these. Apparently, when you get good at this, you can tell where to bend these exactly. Actually, here's a good time to mention I got this collection of things in here. I've got a desoldering pump on suggestion of Dave Jones at EEV blog. He says it's a good idea to have one of these. So I got it, so that I have it. Probably not gonna use it. That's okay. We got flux in a pen, flux pen, Rosen flux type RMA, blah blah blah. Don't need that right now. I got an X-Acto knife, which I also will not need right now. But these, I will not need all of them. But I got a bunch of ESD safe tweezers of all different sorts to aid in the process of touching these tiny things and bending them at particular angles. So, this one's kind of cool if you're doing SMD work, I guess, because you can pick up the thing and then put it down, as opposed to having it at a different angle. Pick up a thing and put it down. I don't know. Personal preference, I suppose. I'm gonna use one of these at least to help me bend this. I don't know. Let me take a look at all the different tips here. Those are pretty pointy. Those are flat. That's pretty decent. These ones are obviously curved. Those ones are super pointy. Those are also pretty super pointy. All different kinds of points. Those are even also very pointy. I'm not gonna go for a very pointy thing. So I need none of these guys. Probably these ones. I'll go with these ones for now. But precision tweezers may indeed be helpful in the process. Put this over here. There we go. Okay, so I'm gonna want this to be pretty flat up to this point. Hell, I should probably use 2 pieces of tweezers. Pieces! Straight up, just 2 tweezers. Pardon me. Making noise. I'll take the stumpy looking ones. There we go. Okay, so we've got that, I'm gonna bend it at a right angle here. Maybe the other one would be. Where is it? Hold on a second. Okay, there it is. Fuck it. Okay, so. Okay. It's kind of 90 degrees, and then bend it 90 degrees there. And then I'll get a relatively decent thingy. That. Probably bring it in a little bit more. Now, one thing I should probably be careful about is making sure that it goes in the right way. So, jumper wire, use discarded lead. That's one of those guys. Question: how do I put it in? Referencing, it says page 4, but I don't know. The question is, resistors, do they have polarity? Meaning, does it have to go in like this, or like this, or does it matter whether it's one way or the other? So that I would like to know before I start soldering. Okay, there my answer, my question. My question is answered right here. Diodes, transistors, and electrolytic capacitors. This is none of those things. So it is not polarized. I think just for continuity, I'll mount them all this way, red left to right, just to make it easy. That's how that goes. Then on back, move this a little bit out of the way, and now we're actually gonna start soldering. Oh my goodness. You can have a bunch of things kind of underneath this to keep it in place, or keep it off the table, or whatever you want to do, but whatever. Alright, turn it on. It's going to do that. Right now it's set to 750 and it should be heating up. Don't breathe in that stuff. Six, 720, 750. We are at 750. So assuming this is live now, it certainly made the right gestures to make itself appear that it was live. So yeah, that smells like heat. I'm gonna do this right here. I'm gonna check one more thing, which is here it says soldering with this type. I'm pretty sure it was like 700. Yeah. Recommended tip temperature is approximately 700 degrees Fahrenheit. So I am going to reduce the temperature right now. If I can. Hold on, let me see here. Here it is. Initial setup, operation. No, it's still trying to go with that. Okay, so I turned it off for the moment while I go back over these instructions. I'm also gonna get this out of the way for the moment. Okay, so I didn't even bother putting the sponge in. Do not use this other than to solder things. Turn on the power switch. After turning it on, 888 will be displayed. Hold on a second here. Ow. Aha. No more room. Hold on a sec. Tisk, tisk. Right now, I'm transferring data. Now's a pretty good time to set this up. Okay, so turn on the power switch and it says 888 for 2 seconds until the current temperature will be displayed. When the display stabilizes, LED heater lamp will begin to flash. And that's the thing in the top right corner. Place the iron in the iron holder when not in use. Turn off the power when not in use for an extended period. Always clean the tip and coat it with fresh solder after use. Making changes to settings. If no buttons are pressed for at least 1 minute during the process of changing settings of the unit, the system will exit and return to operating mode and display the current temperature. Changing the set temperature. There are 2 ways to change the setting temperature: normal mode or preset mode. The temperature setting range is from 120 to 899 degrees Fahrenheit, from 40 to 480 degrees Celsius. By default, the temperature is set to 750 degrees Fahrenheit, 399 degrees Celsius. The normal mode, example, changing 750 to 800, hold down Enter button for at least 1 second. Press the up button once. Change the 7 to an 8. Press the Enter button once. Go to the next digit. Press the up button 5 times to change the 5 to a 0. Press the Enter button once. To get to the next digit, press the Enter button once because that's the digit you already want. Desired temperature is saved to the system memory. The heater control will begin after the new set temperature is displayed. Preset mode. It has preset modes that will allow the unit to store up to 5 preset temperatures you can change between instead of using the above normal mode. The initial number of active presets is set to 5 at the factory. So, let's see. I'm going to turn it on. It says 750. I'm going to wait till it heats all the way up. Seven. 750. Okay, go hold Enter. Then I'm gonna hit Enter. Then I'm gonna hit that. I'm gonna hit Enter. Now, okay, now it is going down to 700. Previously I was just hitting up. That did not change anything. So now it is at 700 degrees Fahrenheit, and that is acceptable to my standards. I think if I switch it off and switch it back on, I'm gonna have to do that again. So while my stuff is still transferring, I'm gonna switch it off, turn it back on again. Right now, still pretty close to 700. Oh, no, it stayed at 700. That's alright. I think what it said was if it stays off for a minute or more. Yes, here we go. If no buttons are pressed for at least 1 minute during the process of changing settings. Well, no, maybe not. I don't know. I'm pretty sure that if you leave the unit on its own off for more than a minute, it will change back to whatever its initial setting is, as opposed to keeping whatever temperature you had selected the last time. So I'm going to change it to a preset mode, and to do preset mode, troubleshoot. Maintenance operation. Performing temperature adjustment. Restricting settings. Parameter settings. Okay. Low temperature error setting. Password setting. Setting mode selection. Parameter setting. Parameter mode. Okay, well, let's check this again. Okay. No, oh, it's desired temperature is saved to the system memory. Preset mode. Initial preset temperatures are 600, 700, 750, 800, and 850. Change the preset temperature. Press the up button once. Let me turn it back on. Press the up button once. I'm gonna wait till it gets the temperature, I guess. Still transferring. Probably gonna take a while. Let it get up to 700. It's at 700. I'm gonna hit up once. And nothing happens. Nothing. Okay. Changing parameter setting. Changing parameter setting. Okay. Parameter entering mode. Hold the up button while you turn on the thing. Okay, so we're gonna do this and hold the up button while I turn it on. We got flashing 1, 3, 11. Hit enter. 0 is normal mode. 1 is preset mode. Enter. Uh, 5P is 5 presets. I'm alright with that. Display will be set to that after, so I'm gonna switch it off now, switch it back on. Now it will have different preset settings. Heating back up again. Doesn't take long. It's going up to 700. Now, let's see. Now hit up. Nothing. That's not what I want to do. Let me try this again. Number 11. Number 1. $5p. Celsius or Fahrenheit. I would like to run in Celsius, but I held enter. I think this is what this is. Changes will not be completed until Y is displayed, and you press the enter button. So, I held enter. So, we're gonna do preset 3. No, we're gonna do preset 2. Okay, so, preset 2, 700. I'll hit enter, just because it probably wants me to do that. And we're back to 700 already. Alright, there we go. Now I know how to use this. Voila. Much better. Not too bad. Not too bad at all. Always good to keep your manual close by, because you never know when you're going to have to reference it. Let me see here. I'm gonna look at this. Still transferring over there. Alright. After you get that thing in, there's a test point. So let's take a look at the test points. Pop one of these out of here. Like that. Now, test point. Legend side, blue side, forward side. So that pops in somewhere. Right there. Test point is right there. So it'll be up in that hole. I'm gonna switch this off because I'm not currently using it. That's the next thing though. Oh, it'll be on this side. There's a jumper over here somewhere. This is upside down too. No, it's upside down this side. There it is. Now, what is a jumper for? It doesn't particularly explain it. This is the point where this will be a good kit when you have somebody that knows what they're doing and they can give you more detailed feedback when you're asking questions and stuff like that, especially with the transistors I was having a problem with before. Just could not understand them. Test point. I can start setting it up a little, but what's next? 10 microfarads lytic. This is a lytic capacitor. C42. There's one. And the -1 is the shorter one. It also points to it and says, hey, this is the -1. Negative. Right here. That's the positive side. Is it? Let's see. C42. This C42 over here. Ah. This is a foil side. Okay, so this actually comes up. Does it? Because it's on the underside. It's this one right here. Just pull it through. Let me take a look at this. Here's a picture of this. It shows everything on the front side of the board. This says that this is on the other side of the board. So I'm calling bullshit on either the picture on the front of the box or this diagram, this figure right here. So I'm calling BS on this. I'm gonna do it like this. We're going to take a look at capacitors. Identifying capacitors. Okay. It does not say I guess the flat side is the plus side. The pluses, that plus input's pretty close to that other one, so it's a little confusing, but now I understand. That associates it with that. That associates with that. So that's the plus side. That's the negative side. The plus side goes, obviously the plus is the longer one, so this one will indeed go like that. So the plus is on the line side. And it says on one of these things, page 16, it says on this to leave a fourth for the transistors, a fourth of an inch, but it doesn't say here. It doesn't say there. The picture here shows this basically lying straight at 90 degrees to the hole, and the one on the front shows it coming directly out of that hole. So I'll just do that. I'm about halfway done with that transfer. Right now I'm videoing with two devices, the live stream, which is my webcam, and taking audio with my microphone, my headset, and I've got another HD camera that I've got up there, which just filled up with video. So I have to empty it and then fill it up some more. All right. Here's one that doesn't even have a plus. This says plus over here. Doesn't say anything over here. But basing on prior knowledge, which is this. Assuming that all these are labeled correctly, then I can just know that the the line side, plus side, parentheses side, negative side. That'll be good enough. Oh. I'm gonna have to go over this again once I get the other camera up. So I could take a pause right now. Still haven't started soldering. Oh, I was so close. But I've got this working now, so that's good. My doodad, my doohickey. There it is. Barely visible. It's like perfectly reflecting the lights. I'm just playing right now. It's a pretty good magnifying glass. We're waiting. This is the boring part. Yeah. I feel the heat up here a little bit. I'll clean this off, I guess. Clean off the pre-solder stuff, previously soldered stuff. Alright, 700. Cleaned off the tip. Now it's ready to get used. About halfway. A little bit more than halfway. Let's see. Not quite entirely stable, but if I would prefer to not be soldering directly against the table for any reason, I could do this. It's a little bit high off the table though. Hell, I could probably just do this even. Clearly, I'm going to edit this afterwards to remove the downtime.
Success.